Hello folks, so in this video I want to talk about how we can create the inverse of a function, and I know that we talked about this already, but I want to talk about this now that we know about one-to-one functions. So what I'm going to do is create an example. So the question we're going to find, the function that we're going to invert is the function f of x is equal to, I'm going to use a parabola here, x minus 3 squared plus 7, pretend. Okay, so first off, let's get a rough idea of what this graph looks like. So you might not remember a vertex form, or you might remember vertex form, and that's totally fine. But remember that we can use what we know about transformations at this point to get there. So I'll start off with my parent function right here, which would be the basic parabola y equals x squared. This is x squared. If I replace that x with x minus 3, that shifts it to the right 3 units. So if that vertex is at the origin, here the vertex is now at 3, so that'll go right here. Maybe I should do this in different colors. This red one here, that would be x minus 3 squared. And if I want to bump it up 7 units, I just have to add 7 to all those y values. And so that'll be this green one right here, pretend. Okay, so actually, let me just draw this nicer now. Our graph is actually going to look just like this, right? And our vertex right here is at 3, 7. Okay, now we got that out of the way, I want to create the inverse of the function. Now, if we just draw what the inverse should look like, well, we know that the inverse is going to, again, be inverted over, or flipped over, the line y equals x, and look something like this in red. But remember, we want the inverse to be a function. And so the original function as is, when I invert it, will not create an inverse that is a function. Let me say that one more time just so we're clear. If I just take this whole parabola and draw the inverse, that now sideways parabola is not going to be a function because it won't pass the vertical line test. Okay. So what we need to do is restrict the domain one. So since f of x is not 1 to 1, 1 to 1, we must restrict the domain. And again, this is all because we want the inverse to be a function. And we'll see why that matters in a later video. We must restrict the domain of f. And so we actually have two options here. You have really two options because you could take either the left half of the parabola or the right half. So let's just pretend we wanted to take the left half. So I'm going to say f of x, again, is equal to x minus 3 squared plus 7, and I'm restricting my domain where x has to be less than or equal to 3. Okay. Now that we've got that out of the way, we can simply go about finding the inverse just like we normally would. So if our original function, again, is y equals x minus 3 squared plus 7, then I can now take the inverse by flipping or replacing x for y and y with x. Y minus 3 squared plus 7. Okay, I'm not going to go through this whole process here, but I think we should end up with x minus 7, the square root of that, plus 3 here. And that's going to equal y, or in other words, our f inverse of x, right? Alrighty, so now let's also remind ourselves what our domain and range of our original function are going to be, of our inverse are going to be. Now, if we take a look here, we know that on the original function, our domain that we picked out was x less than or equal to -3. We can also see that the range, well, based on the vertex, we know what the range is. We know that the range is going to be y is greater than or equal to 7. Okay. Now, think back to how an inverse works and what it does. Since it essentially just exchanges x and y, what was the original domain becomes the new range, and what was the original range becomes the new domain. And so for us, this means that our new domain for, again, f inverse is what was the original range. So since the original range was y is greater than or equal to 7, this says our new domain is x is greater than or equal to 7. And likewise, our old domain that we picked out was x is less than or equal to negative 3, or sorry, less than or equal to 3. So our new range is y less than or equal to 3. Okay, so what I'm going to do is I'm going to take this original function and our inverse and throw it into Desmos. Alrighty, so here's the original function. You can see in red here, x minus 3 squared plus 7. And we have our vertex once again here at 3, 7. And now what I'm going to do is, well, we chopped off the graph, so we only took half of it to, again, ensure it was 1-to-1, and therefore the inverse would be a function. So that was this graph. So we only took the left half in purple here. The inverse that we got was, or coming up with the equation, was x minus square root of x minus 7, excuse me, plus 3. When I graph that, something looks a little off. Now it has the right shape because again it is a square root graph, which makes sense because the original was x squared. But something went wrong here. If we check, and the math we did, I think algebraically checks out. I don't think we made any mistakes there. But graphically, we can see that if I flip the purple graph over x, the line y equals x, this orange line of symmetry here, it's not going to land on top of the green one. So what happened? Well, we need to go back to our work here and think about what we actually did. Remember, we took the left half of the graph here. But what could potentially happen when we're taking the square root right here is that the square root could actually be plus or minus. And so we have to keep that in mind when we're actually taking the inverse. So what this should actually be is that this should actually be the negative square root of x minus 7. If I do that, I think that will fix the problem. And we can see that right here, that it will flip it upside down and we'll get the right image. Okay. If I had changed it slightly, now let's copy this. And instead, I want the right half of the graph, which will be, oh, sorry, before we even go there, notice here again, our domain for this graph, again, starts off at x equals 7 and then goes onward forever, which is what we said right here. And also, it now fits where we have y equals 3 and then goes down. If I had checked this, or just left it there, we can see that the range is already wrong, right? Because this is greater than or equal to 3, but it should be less than or equal to 3 here. If I took this exact same graph though, and I'll copy it here, that would be the inverse of the other half of the parabola. Oops, sorry. And we could see that right there. Oops. And we can see that there. Okay. So when you have a function that is not one-to-one, step 1 to find the inverse is to restrict the domain so that it is one-to-one. Right? If I just take half of the parabola at this point, it is indeed one-to-one. At least that piece is. Now you know that when you invert it or find the inverse, that result will actually be a function, and now you're good to go. Now you're just going to need to be careful of when you're doing this, and to just again double check your work, right? You can always double check it by graphing it. Okay, so thanks for watching. I hope this helps. We'll do a couple more examples, or I'll find a couple more for you to check out. Alrighty, so I hope that helped. I'll see you around.